Hello and welcome back to Advent of Cyber. This is day 19, ICS, Modbus. Okay, so the story for today is the snow falls heavily over Wareville as chaos erupts at the TBFC headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg, shouts a frustrated warehouse worker holding up yet another Easter-themed package. We're supposed to be shipping Christmas presents. The delivery drones buzz overhead, their mechanical hums sounding almost mocking. Each one returns from its routes empty, having successfully delivered its cargo. But the cargo is all wrong. You're called into command center where the screen flickers with delivery statistics. Everything looks normal on the surface. 1,000 presents in stock, 98% success rate, and all systems are operational. But the phones won't stop ringing with confused citizens asking why they're receiving chocolate eggs instead of the toys and gifts they ordered. The logistics manager pulls up a delivery manifest. Look at this, she says, pointing at the screen. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but completely different items. Then, on one of the monitoring screens, a screen flashes for just a second before disappearing. Why should Christmas have all the fun? From King Malware. A mysterious discovery. As you walk through the warehouse control room, something catches your eye, a crumbled piece of paper on the floor near the PLC terminal. It looks like someone dropped it in a hurry. You pick it up and unfold it. The handwriting is hurried, almost frantic. You stare at the note, confusion washing all over you. Register map, coils, what is all this? The terminology is foreign, HR0, C11, Modbus scribbled in the margin, but something about it feels important, like a key you don't yet know how to use. You pocket the note carefully. I'll figure out what this means later, you think. For now, you need to understand the systems you're dealing with. Little do you know this crumbled note will be exactly what saves Christmas. So today's learning objective is going to be learning how SCADA works, supervisory control and data acquisition systems monitor industrial processes. We're going to learn what PLCs do in automation. We're going to learn how the Modbus protocol enables communication between industrial devices, how to identify compromised system configurations in industrial systems, techniques for safely remediating compromised control systems, and understanding protection mechanisms and trap logic in ICS environments. So connect to machine, we've already done that. So what is SCADA? SCADA systems are the command centers of industrial operations. They act as the bridge between human operators and the machines doing the work. Think of SCADA as the nervous system of a factory. It senses what's happening, processes that information, and sends command to make things happen. TBFC uses SCADA to oversee its entire drone delivery operation. Without it, operators would have no way to monitor hundreds of drones, manage inventory, or ensure packages reaching the right destinations. It's the invisible orchestrator of Christmas logistics. So the components are sensors and actuators. We have PLCs, we have monitoring systems, and we have historians. SCADA in the drone delivery system, package type selection, drone delivery routing, visual monitoring, inventory verification. We have system protection mechanisms. We have audit logging. Why SCADA systems are targeted. Industrial control systems such as SCADA have become increasingly attractive for targets for cyber criminals and nation-state actors. Here's why. They often run legacy software with known vulnerabilities, default credentials, or commonly left unchanged. They're designed for reliability, not security. Most SCADA systems were built before cybersecurity was a significant concern. They control physical processes. They're often connected to corporate networks, and protocols like Modbus lack authentication. In the early 2024, the first ICS OT malware, Frosty Goop, was discovered. The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes to device registers over TCP port 502. King Malware has weaponized the same tactics, not to cause blackouts, but to sabotage Christmas deliveries by directly manipulating the control systems through the Modbus protocol. In the next task, we'll explore the PLC, the component he's actually compromised. So it says what port is commonly used. That port is going to be 502. So this one is, what is a PLC? A PLC is an industrial computer designed to control machinery and process in real-world environments. Unlike a laptop or smartphone, PLCs are purpose-built machines engineered for extreme reliability and harsh conditions. PLCs are designed to survive harsh environments, run continuously without failure, execute control logic in real time, and interface directly with physical hardware. What is Modbus? Modbus is the communication protocol that industrial devices use to talk to each other. Created in 1979 by Modicon, it's one of the oldest and most widely deployed industrial protocols in the world. Its longevity isn't due to sophisticated features, quite the opposite. Modbus succeeded because it's simple, reliable, and works with almost any device. Think of Modbus as a basic request-response conversation. The client is your computer. POC, what's the current value of register 0? The server, POC, responds, register 0 currently holds the value 1. The simplicity makes Modbus easy to implement and debug, but it also means security was never a consideration. There's no authentication, no encryption, no authorization checking. Anyone who can reach the Modbus port can read or write any value. It's the equivalent to leaving your house unlocked with a sign saying come in, everything's accessible. So the Modbus data types are coils, discrete inputs, holding registers, and input registers. So in TBFC's drone control system, you'll find holding registers and coils. So a critical detail is Modbus's addresses start at 0, not 1. This 0 indexing catches many beginners off guard. When documentation mentions register 0, it literally means the first register, not the second. So the security problem with Modbus is Modbus has no built-in security mechanisms, which means no authentication, no encryption, no authorization, and no integrity checking. So connecting the dots, now that you understand why the OpenPOC web interface showed nothing useful. King Malware bypassed it entirely. He connected directly to the Modbus TCP port and manipulated the registers and coils that control system behavior. That note that you found, the maintenance technician must have discovered what was happening and started documenting the compromised values. The warning at the bottom, never changed, suggests they figured out the trap mechanism before getting interrupted. In the next task, we'll use Python and the PyModbus library to investigate the system exactly the way King Malware attacked it by directly reading and writing Modbus values. Time to see what he actually changed. Now that you understand how the system works, the mission is yours. Hack it back and save Christmas. So there's no question for this section. Alright, so visual confirmation, the CCTV feed. Before diving into technical details, let's see what's physically happening in the warehouse. So we're going to navigate to this link. And as we can see here, we're met with a status compromise, disarmed message at the top, and we can see a bunch of what looks like suitcases or motorcycle helmets filled with eggs. Okay, so Modbus reconnaissance, we'll need to interrogate the Modbus server directly. This is where Python and the PyModbus library become essential. Remember that crumple note you found earlier? Pull it out now. The terminology seemed foreign. HR0, CO1, Modbus is about to make perfect sense. So it says here, steps 1 to 5 are optional, and you can just read along with them. So we can pretty much skip these. Let's see how many questions are there. So there's only one question, so we can pick up at step 6. All right, so complete reconnaissance script. Let's create a comprehensive script to see the full system state, exit the Python interpreter, then create a new file. Okay, so let's go back into the terminal. We're gonna do nano reconnaissance.py. Let's see, and we're gonna paste the following code. We're gonna save and exit. Okay, so then we're gonna run our script. And we see here, threat assessment, exploit framework detected, protection mechanism active, trap is set, package type is forced to eggs, inventory verification is disabled, audit logging is disabled, remediation is required. So self-remediation, based on our reconnaissance, we need to disable protection mechanisms, change package type to Christmas gifts, enable inventory verification, and enable audit logging, and also verify C15 never got armed. This order is critical if we change HR0 before disabling C11, the trap triggers. Create the remediation script. So we're gonna do that here, and then the code for that. Remediation is going to be here. Let's go ahead and copy. And then we're going to save, exit. And now we're going to run that script. So it'll be Python 3. There we go. We can see it's going through all the steps, verifying system state, disabling protection mechanism, setting package type. And it looks like it's done with that script. So we can see success, Christmas is saved, Christmas deliveries have been restored. The drones will now deliver presents, not eggs. Check the CCTV feed to see the results. So we have our flag here. And now we can go ahead and refresh this so we don't have to see this evil bunny. Well, I guess we still see the evil bunny, but we can see at the top, system has been restored. But we did get that flag, so let's go ahead and put that here. Egmas over. So if you enjoyed today's room, feel free to check out our OT challenge, Industrial Intrusion. If you want to check that out, feel free. But we're going to go ahead and close out for today. And we are done. If you enjoy watching the video, please hit the like button, hit the subscribe button, follow me on Twitter at rxsklife, and I will see you tomorrow for the next box.